The angle of elevation from the top of a small building to the top of a nearby taller building is 46 degrees 40 minutes. And the angle of depression to the bottom is 14 degrees 10 minutes. If the shorter building is 28 meters high, find the height of the taller building. Okay, so remember, with angles of elevation, angles of elevation and depression are always relative. It's angles relative to the horizontal. An angle of depression is below the horizontal. An angle of elevation is above the horizontal. Okay, and when it comes to, so you might be wondering, well, how would you know these angles? Well, I'm not an expert in surveying, but it seems that there's methods that allow you to figure out what the angles are between objects, even if those objects are at a distance. So that, like, I want to say those surveying apparatuses that you see that they're using, they allow you to determine angles between objects. And so, and I'm assuming with high precision. And so it's interesting to think about how you could be here and you could determine, like, what is the angle of elevation between the top of the building and your position, your measuring position here. That would be the angle of elevation relative to this position. And then you could also find out what the angle of depression is relative to your position. And so with that, if you know the height of your height above ground level, then with that information, what's the height of the building? Okay, so we can use trigonometry to figure this out. We want to add this height to this height, right? We'll call this A and B. So X is equal to A plus B. Well, actually, and we know B. With B is 28. So X is equal to A plus 28. See, B is 28. So we just need to find A, and we can use, let's see, we can use tangent, because we'll get the tangent of this angle is opposite over adjacent, but we need to first find what the adjacent is, which you would think they could measure that easily, but I guess not. So the tangent of this angle is opposite over adjacent. So, but we could do cotangent to make it easier. So the cotangent of 14 degrees 10 minutes. What is 10? What fraction of a degree is 10 minutes? There's 60 minutes in a degree, so 1/6. So 14 and 1/6. Cotangent of 14 and 1/6 degrees is equal to, not opposite over adjacent, but adjacent over opposite. So we'll call this distance C. So C over B, which is 28. And we're not following the precision, the significant digits. We're just ignoring that for these problems, focusing on the trigonometry. Okay, so C is equal to 14 and 1/6 is, so 14 times 6, so 85 sixths. 85 divided by 6. Okay, so cotangent of 85 sixths times 28. We want to do a control enter to do the approximation, because we're going to need to get an approximation. They can't give us the exact answer to this, right? If we tried to get that as an exact, it would just return this. So C is 110.926, so about 110.9, and that's in meters. Okay, so we can say that A is, we'll do tangent of 46 degrees, and then 40 minutes is what in degrees? It's 2/3 of a degree. That's opposite A over adjacent, which is C, 110.9. So A is equal to, you've got, well, okay, 46 times 3 is 138 plus 2, so 140 over 3. Tangent of 140 over 3 times 110.9 is that. That's A, 117.5. Okay, but what's X? What's the height of the building? It's just A plus B, so this plus 28. So we'll round that up, so 146 meters. The height of the building is approximately 146 meters.